Howdy, AP PreCal. It's Ms. Kosh. Welcome back to the notes from 312 from Vicki Carter. So thank you for posting those for us. I have video number 1. I have video number 2, deals with sum and difference. I have video number 3, deals with double. And then now we have to solve trigonometric equations and inequalities using identities. Okay, so here we go. They're telling us to live in the world from 0 to 2 pi. We get one time around the circle. And now I see this equation, sine 2x plus 2 cosine x equals 0. I need, if I have different things happening here, like sine of 2x and cosine of just 1x, I need to get everybody in terms of each other. So it's really, unless I got down to, sorry, if I had something like sine of 2x times cosine of x minus 1 equals 0. If I can set something like that equal to 0, well, then I could set this. I could say, okay, sine of 2x equals 0 and cosine of x equals 1, and then I can solve from there. But that's not a usual thing, and notice they're being separated with multiplication. This is different. So here I've got these things that are being added on to each other. Come back in 10 minutes. Okay, so on this one, I need to rewrite this using my identity. And that would be 2 sine x cosine x plus 2 cosine x. And now what I notice is I can factor, equals 0, my bad. And I can factor out the 2, I can factor out the cosine, and I'm left with sine of x plus 1 equals 0. Okay, so cosine x would equal 0 or whatever. Sine x equals negative 1. When does cosine x equal 0? Cosine is the x value, that's pi over 2. Pi over 2 plus pi k, because on the unit circle we're here and here. Well, we already live in this world. Okay, so pi over 2 and 3 pi over 2. When does sine equal negative 1? Sine is the y value, it's negative 1 right here. We already wrote it down. So, I mean, technically there it is, but whatever. So our two answers are those. That was fun. Okay, then it says solve the inequality. Okay, so these get a little bit more hairy, more interesting, but it's also the same thing we keep doing over and over and over again. Remember, we've done inequalities for everybody. We did log, we did exponential, didn't we do exponential? We definitely did polynomial, we definitely did rational, and now we're doing trig, and trig with advanced identities. So we're looking at, here she gave us this, I would have just done, did I do that? I don't think I did that wrong. I would just include 0, I would include 2 pi, because that's the world we're living in. I would include pi over 2 and 3 pi over 2, and I wouldn't include pi. I understand why she did, because she didn't want to give away the answer, but to be honest with you, I would not have given you a number line. So, okay, so let's look at, I need more paper. Let's say that f of, this is how I have been doing them, f of x is equal to the sine of 2x plus 2 cosine x. So I want something between 0 and pi over 2. And that could be f of pi over 4. I don't know. Okay, so this is sine of 2 times pi over 4 plus 2 cosine pi over 4. This would equal sine of pi over 2 plus 2 cosine pi over 4. I guess I'll save all the unit circle for now. And then this sine of pi over 2, that's equal to 1. This is plus 2 times cosine is root 2 over 2. So this is 1 plus root 2. This is going to be positive. And what were we trying to do? We were trying to see where is it positive. Okay, so this would be a correct, or an interval that we want. Okay, let's see f of pi. Sine of 2 times pi plus 2 cosine of pi. This is equal to, sine of 2 pi is 0. Cosine of pi is over here. That's negative 1, so this is plus 2 times negative 1. This is negative 2. That is no good. That's not in the interval that we want. So no good. And then let's try something between 3 pi over 2 and 2 pi. And that would be, let's say 3 pi over 2 is straight down, 2 pi, 7 pi over 4. Do you see that if you don't know your unit circle, life gets hard? So when I made you memorize it and erase and all those sorts of things, it was for your own good. Okay, there we go. So this is sine of, 7 pi over 2. I should put parentheses to make it look better for you, but whatever. Plus, 2 cosine of 7 pi over 4. Where is 7 pi over 2? Well, here's 0, here's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Oh, you can't see me. 0, 1, 2, 3, 4, 5, 6, 7 pi over 2 would be down here. Okay, so what's that sign value? What's the y? It's -1. This is -1 plus 2 times down here. This is a positive x value, root 2 over 2. This is -1 plus root 2. Root 2 is bigger than 1, and so a positive root 2 minus 1 is still going to be positive, and so this works for us. So, assuming I did this correctly, our answer is 0. Does it equal 0? Okay, since she put an equal sign here, let me think about this for a second. If I plug in 0, I have sine of 0 is 0. Cosine of 0 is 1 times 2. This is greater than 0, so we actually should have a hard bracket here because of the equal sign here. So that is, when I plugged in 0, did you notice I just got 2, which was positive? So we're going that, but if I plug in pi over 2, it would equal 0. Union 3 pi over 2. And then she did not have an equal sign here, so this would be a 2 pi with a soft bracket. Cool. Okay, let's try this last problem. I see sine and addition, so it's sine, cosine, cosine, sine. So sine x cosine pi over 6, the same SIGN, cosine x sine pi over 6 equals 0. Okay, so now let's see what's happening. Use a trigonometric identity to solve for that. Okay. So now cosine of pi over 6 is so this is sine of x times root 3 over 2 plus cosine of x times 1/2 is equal to 0. Oh, I lost the x. That's bad. That's bad. Oh, this is where I should have practiced ahead of time. Use a trigonometric identity. Okay, if I multiply everybody by 2, I get root 3 sine of x plus cosine of x equals 0. Oh, okay, I could manipulate this and get something in terms of if I divide through by, well, sine over cosine. If I divide through by cosine x, I need more paper. Okay, now what I have is root 3. I'm going to come back later and be like, oh, here was a better answer. Why didn't I do it this way? Now I could divide by root 3, so tangent of x is equal to a -1 over root 3, which when you get the, when you rationalize the denominator, it's negative root 3 over 3. Tangent is slope. I want slope is negative in these quadrants. Negative root 3 over 3 is going to be that more steep one. So this is 5 pi over 6 and 11 pi over 6. And then that's all we need in that world. Yeah. So it's those two. Another way to think about this one is that if I come back, okay, it said to use a trig identity, and I did. So the answer, x would equal to 5 pi over 6 and 11 pi over 6. The other thing I can do is I can think about, I need more paper. I could think about my graph. Okay, and so if I think about this, my sine curve, sine of x plus pi over 6 has been shifted, equals 0, has been shifted to the left pi over 6. So sine usually starts here and does this, but now we shifted to the left pi over 6, and so where did I hit 0? Well, it had been at pi, minus pi over 6. This is 5 pi over 6. And then we come, and this one had been at 2 pi, but we shifted it to the left pi over 6. So that's 11 pi over 6. In multiple choice, they don't care how you get the answer. But the direction said use a trig identity, and this wasn't using a trig identity. So hopefully that was helpful. Go practice, subscribe to my channel, and I'll see you later.